I'll be conducting today's session on steel design using Design Plus and Gen. So if you're able to hear my voice clearly, just let me know through the questions tab. Otherwise, I'll help you out with the settings. You can type into the questions tab and let me know if my voice is audible to you. For those of you who've just joined in, a very pleasant day to you. I am Karan Taneja from the technical team at Midas IT, and I'll be conducting today's session on steel design using Gen and Design Plus. So if you have any problems with the voice quality or if you're not able to see the screen properly, just let me know through the questions tab so that we can proceed further with this session. Okay, since everyone looks like they're comfortable with the voice quality, so I shall proceed further now. So today we're going to be talking and I'll be showing you about the design capabilities of Design Plus with regards to steel buildings. So this is the structure that we're going to design in Design Plus. This is a steel and SRC structure, both. All these columns here, they are from the SRC material, and the rest of them, they are steel columns. These are the braces, and these are the girders. So for those of you who have earlier attended the webinars, the basic design can be done in midas Gen only. That means you can do the column and the beam design in Gen. So when you do that, this sort of a tab opens up in which you can see whether the member has passed or failed the design criteria as per the code selected. So this is this contains the design results of this structure for steel materials. So the ones in blue show the sections that have passed, while the ones in red, they show that the section has failed in one or the other criteria. Another way to note is the OK and the NG, that means not good. These are the sections that have passed, and these are the ones that have failed. So in Gen, you can do the design get the text design report. For example, like if I want to see the design report of this girder, I'll select it and click on detail, and in a text format I'll get all the checks performed based on the British code with the clause and the line and the page number mentioned. So you can see the classification of the section, the axial check, the shear check, the bending capacity about the major and the minor axis, the lateral dorsal buckling. All of this is available in a text format. Similarly, you can get details for other materials. So today we're going to be focusing mainly on the design capabilities of Design Plus, which when used in combination with Gen will give you a very powerful feature for designing a steel structure. So to access Design Plus, you can go to Tools and click on Design Plus, or otherwise you can directly double click on the Design Plus icon, and this sort of a window will open up. It will be there on your screen in just a second. Yeah. So this is the user interface of Design Plus. For those of you who have attended the previous webinars, we had done RC design using Design Plus previously. So today we'll be focusing on steel and the SRC design. So firstly, I'll show you how to link a Gen model to Design Plus so you can be very comfortable with the design. Just have to click on this icon, and the Gen file which is open, you have to click on it and click on connect. So as soon as this sign turns green, there'll be a message at the bottom that says successfully linked with so and so file. So now you can proceed further. So firstly, I'll show you the beam and the column design. This is just the same as in Gen. I'll right click on add, and you must be wondering, why have I linked with Gen? I'll just show you why I did that. So I have selected beam and column here, okay? So let me pick any beam. I've picked these beams and also a few of these columns. These are all steel, remember. Now I can go to Design Plus and click on import. So you'll notice that the girders as well as the columns, all of them have been imported with the forces and the moments that they are experiencing, which will be used for the design purposes. This is the member number 47, 49, 50, 55, 61. So you can easily identify which member I am designing. Now here I can either change the material, manipulate the design according to my wishes. If I want to check for torsion also, you can do that. So I'll just click on design, and towards the right side of your screen, you'll see the checks performed, whether it's okay or whether it's lacking in some aspect. These are the section properties, and these are some of the features which are available for the seismic design. You can either keep it as a special movement frame or an intermediate movement frame, ordinary movement frame, concentrically braced frames, eccentrically braced frames, buckling restrained braced frames, and special plate shear walls. All of them can be done. I hope my voice is audible to you. If you're having any problem with the voice quality, just let me know through the questions tab. If I am either too loud or any other thing that's troubling you. Okay, so we'll proceed further now. So now there are many members. So it is tedious to go to each member, then click on design. So the easier thing to do here will be to go to the member list. Now from here I can easily design all of these members in just one click. So first I'll just select them, and here I'll tell the section. In fact, the program has already identified which is a beam and which is a column. I just have to select them, right click, just select these members. In fact, I'll click on all, and I'll just click on design. So it has done all of these members, and they have been designed as special movement frames. So here they are. Just click on these. Just a minute. So it had designed all of these sections, and you can see the checks were formed for the axial force, bending in X, Y, shear force, and the combined forces. So if I want to change anything, let's say I want to change the material of the beam and then see. So it's very, very easy. Let's say I'll just change the material of this beam. Click on A53, select this. Now I'll just click on check. So you can manipulate and see, and economize your design by changing various parameters, and then whether they're satisfying the criteria or not. So as you can see, it is coming in red. It's almost 1.2% more than the required. So we can even change it further. Again, click on check, and this time it's coming out okay. So it's these small little things that make your design quite fast. And the best thing about this is it gives you a complete report in a Word file. I'll select this member and click on report and click on detail. So by the time you go and have a cup of coffee, your report will be generated. So this is the design code, the unit system, material, effective length, section properties, the PM interaction curve, all the forces that were required, the axial strength, flexural check. This is all according to the codal provisions. So it gives you a measure of control on your design so that you can check whether the program is doing it correctly or not, and whether you need to change certain parameters or not. So after beam and column, the next thing that can be done is the base plate. You go to base plate, double click on it, And to do base plate design with respect to gen, I'll go back to the midas gen file, and here I'll first unselect all of them, go to the bottom and select a few of the bottommost nodes where my base plate shall come. Now I'll go back to Design Plus and I'll click on Import. We'll go back to the base plate and see that with respect to each of these columns, it has imported all the forces and the moments as well as the shear force that is experienced by the support. You can click on the load combinations and check which combination it is considering. And you can even add your own. So it's very easy to, tinker with the design and see which fits your purpose better. So I'll just delete the last of these. Okay. Now I'll click on OK. Anyway. All. So this is how we can select the design. Now I'll just select the anchor bolt material. There are two types of base plates that are available, the rectangle and the circle. I'll show you the rectangle first, whether you want to place it on a pedestal or not. We'll first do it without the pedestal. And it gives you an option whether you want to use a rib plate or not for the design. And according to that, the figure changes. So whether you want to increase the number of rib plates, and you'll see that as soon as I increase the number, the anchor bolt number also increases. This is happening because I've checked on this number, which is get number from the rib plate layout. So according to the layout, it checks where the spacing is viable, and there it fits the anchor bolt. So I'll just click on design. And right here it's showing me all the checks that are satisfying, and it is passing all of these criteria. Now this is not the base plate design is just not limited to this. You can see the section and the layout. You can see the base plate movement diagrams also. This is the MYY, the shear force diagram, and it also gives you the moment diagram for the rib and the wing plate. You can see the contour values here, as well as the shear diagram. Also, it gives you the bearing force diagram, which tells you which all areas are under compression and which part of the base plate is under uplift. So this is all under compression. This part is slightly uplifted. And if there is a tension force in the anchor board, it will show you. Otherwise, if there is no tension force or it is very, very minimum, it should show a message like this: tension force does not exist. So these are some of the things that can help an engineer. Also, let's say now we want to change the base plate size and see whether a circle is good enough or not. You can change the thickness. Let's keep it at 28. And here we'll use the wing plate also. Thickness of 9 mm. The height of 100 meter. sorry, 100 mm. Click on check. So it's showing me that the wing plate is inadequate. So I'll click on design and let the program first tell me. Okay, so we need to increase the size of the base plate. Click on 6, almost 600 will go back. 650, that seems fine, yeah. Now we'll click on check. Okay, again it's showing me that the dimensions are too near. I'll click on 700. Let me increase the size a little more and then we'll see. Yeah. So it's 775, it's showing me that it is okay. But again, it is failing in the moment. So we'll have to tweak things a little now. We'll increase the thickness to 36 and then check. Yeah, so right now it's passing. It's almost 0.8. So that means this section is fine. You can change the diameter of the anchor bolt from here. And you can even change the dimensions or the position. So the same thing that was there in the beam and the column, the member list is available here also. The another major plus point of Design Plus is that it gives you the section drawings. So I'll just click on create. And also one other good thing is this is completely compatible with AutoCAD. I'll just click here. Window. So we'll specify the first corner and we'll zoom in a little more. So this is the rectangle and this here is the circular base plate, the rib plate and the wing plate that we used. Both of them are here. This is one of our own created CAD programs. So every command that you use in AutoCAD, it's available here also. Okay. So we'll move on. Now we go to the bolt connection. So this is a feature for the splicing. I'll just select a column and some of the beams here. And now I'll import them into Design Plus. So we'll first go to the girder. For girder splicing, you can, if you want, you can change the material. Otherwise, we'll move on further. And it designs for the 100% strength, and it has automatically picked up the moment and the shear generating from Gen itself. The material of the bolt can be changed here. We'll just keep it at A325 now. And now we'll just click on design and see whether the program is giving me a suitable design value or not. So as you can see that these bolts, the bolt numbers are a little on the high side. So we can, reduce them by just going on web, number per side and bringing them down, let's say to 10 first. And I'll click on check and see. So it shows me that it is just failing in the combined category for the bolt. I'll increase the diameter and check again. Yeah. So now it's coming out to be quite okay. So you can, this is how you can tweak the design according to your comfort. For the flange, I'll again decrease the number, bring it down again to 10, click on check. So it's still on the safer side. That means you can reduce it further. Okay. And again, all of these members. So this was the girder splicing. Now we'll go to the column splicing. So again, this is almost similar to the girder splice. You can change the beam and the column material, the material of the web of the plate used for splicing. And let's first see how it, if the design is okay or not. So yeah, it's okay, but again, it's on the safer side. So I can reduce the number, bring it down to 10. So it's a little on the higher side for the combined. I'll increase the diameter. Click on check. And increase the thickness also of the web. So now it's okay. So you can see how easy it is to tweak the design and economize your sections for the splicing. And let's say you want to have a shear connection. So I'll go back to one of the girders, click on shear connection. So whether I want a single shear or a double shear, that depends on me. And again, it will design for the 100% strength. I'll just click on design first. Yeah. So again, it's quite okay. It's 0.93, so it's fine. For the shear also, it's very, very safe. So you can reduce it, bring it down. Let's say we'll check with 30 first. Okay, so it's a little more on the higher side. We'll increase the diameter. Yeah, so it's quite safe now. It's very, very safe. And again, you can get the design section also. So I'll just click on create. And you can either scroll in, or as I've shown you before, since it is compatible with AutoCAD, every command of AutoCAD, you can type in zoom and zoom in. You can create lines or insert text. That's all upon you. So it will be there on your screen in just a few seconds. I hope it's visible on your screens now. This is the drawing generated by Design Plus for the sections. Column splicing and the shear connection along with the girder splice. So now we'll move on, and the next thing is the crane girder. I'll double click on it, and here you can select the material. We'll go for A53. Select the type of section. I think this is enough now. Give the cover plate thickness as 10. The girder as 10 meter, and the rail width we'll give a little higher. Go to 70. And we're not to check for back trusses or stiffeners now. So this is the wheel load that we are going to apply for the cranes. If I want to add or change it, I can change it by just typing it. And if you want to increase the distance, that is, you can do it from here. Let's say you want to keep it at 3 meters. If you want to add some more loads, you can do so. 50 at one more meter. So it's relative to the last wheel. Yeah. And you can consider the self weight. The impact factor is based on the code. And the fatigue, you can change the number of loading cycles. The criteria for deflection. And if you want to check for horizontal deflection also, you can do it from here. So now we'll just click on design. Yeah. So it's showing me that it is safe, but the horizontal section, the horizontal deflection is too much. So for that, I think we need a back truss. Now with the back truss, let us see if it's failing or if it's passing. Yeah. So it is completely okay for the serviceability, and the stiffeners used are at a width of 300 mm with a spacing of 1.5 meters at the ends, and the mid stiffeners at a spacing of 2 meters. So this was serviceability and the stiffener check. For strength, it is very safe. You can see it's almost 3.5%, and here it's 26% of the design force. And if you want to check or verify the design forces, you can go to the last tab, and here you'll see the shear force or the moment generating. This is the section view and this is the wheel view. We'll just go to the design now, the drawings. Click on create and zoom in. So this is the plan, and this is the elevation. This is the crane girder. This is the distance between the end stiffeners. This is the distance in the mid stiffeners. So this is how you do a crane girder using Design Plus. The next thing that I'm going to show you is the purlin and the girth. So let's go to PG01, select the material. I'll go for A36 and I'll first design a purlin. I want to give it a channel section. The span I'm giving it 3 meter and a spacing of 1 meter. So it's 2 spans, and I'll just enter the live load. Let it be -3. Okay, so I'll give it 3. A dead load of again 3. And when this is the pressure, that will be 1.45. This is the windward coefficient, the due to positive pressure, and 1.15. This is due to the negative pressure. I'm not taking any snow loading, and I've settled the deflection criteria at L by 300. So we'll click on check. And we can see that it is quite okay. So it shows you whether it's classified correctly or not. This is the compact section in both the web and the flange. And both in X and Y direction, the movement is okay. So we'll go to the drawing, and now we'll see the drawings for the purlin and the girth. So for purlins, it's like this. Same way for the design. And you can get the report also. I'll click on detail. For purlins, it will show me a complete detailed design report section, the PM interaction curve, span, unbraced length, the deflection, the design load, and the checks performed. So all of this is available in in Design Plus. And this is there for the Euro and the American codes. And the next thing is web openings. So this is quite important. So I'll first select the materials for the beam, the plates and the studs at the top. This is for a composite beam. If I want a steel beam, I can go to the steel beam option. I'm just keeping this section as this, and the opening I can keep either a rectangle or a circle. The span is 12 meters with a spacing of 3 meters. And this is at a position of 6 meters with 0 eccentricity, and the dimensions are 600 by 300 mm. And the corners are 34.54 mm. So whether I want to enter the design load directly, the moments and the shears, I can keep a unit load of 10. We'll reduce it. Let's say 7.5. Sorry. And whether I want to add a concentrated load, I can do it from here. And if I want to reinforce the opening or just keep it like this, that depends on me. Use a double plate. So I'll click on design. So it's showing me that it's a little unstable. So maybe we need to reduce a couple of things. Let's say we can increase the thickness first and then check. It's a little unstable. Maybe we need to reduce the size. So that depends on the engineer. So you can see how Design Plus is going to make this task very easy for you. You don't need to go back to your Excel sheets. You can use this. You can go to drawing and you can see the design drawings. You can see the position of the stiffeners also. This is for both and this is for a single. Let's say I'll go for circle now and then I'll check. Click on design. And it has automatically decided the thickness at 6 mm with a width of 60 mm. So these are the design capabilities for steel design in Design Plus. The next thing, which is a bonus, is the SRC column. So I'll just select the SRC system. You can change from RC to steel to SRC from here. Go to SRC, select composite beam, and I'll go back to Gen, unselect, I'll add a beam. Yeah. So this is the material for the edge beam, the material for the stud, and the concrete strength for the concrete deck above. I'm keeping it at M25, 25 MPa. And slab thickness, I'm keeping it at 150. Whether I want to use a T shape or a half T shape, this is for the ends. I'll use a T shape, and if I want to use a deck plate or not. And the direction is parallel or perpendicular to the beam. We go for perpendicular first. And the headed stud, I can increase the number of these studs, which is a maximum of 3. Spacing and all I can check from here. And if I want to use a user defined section, I'll increase the width, go to 500. So this is how it's done. And the best thing about this is you can get a vibration chart also. So I'll first design it, and I'll give the live load as 2 and the finishing load as 1.5 in considering the self weight. Click on design, and in the vibration chart it is showing me I have selected for the office type. So it's showing me that it's quite safe. You'll have to squint a little. So this is the chart for the frequency and the acceleration, the peak acceleration. So the red dot indicates your composite beam, and these indicate the limit for a particular type. So in fact I have selected office, so this is safe enough for an office floor. I can use a load, I can increase or decrease the load factor and also change the damping ratio. And the connection type I have kept as a moment connection. And the girder section I can change from here. And again I can click on report. Go to the Word document. And here you can see the member name, the material used, and all the checks that were performed in the design for the SRC beam. So since it is a compact section, it is doing the plastic design. The effective width of the slab, all of that has been calculated. The design forces, the combined strength. So this is a very, very detailed report which the design engineer can verify and go through. So you can see that after combining it with Gen and also using it separately for certain functions, Design Plus is a very, very useful feature, and it should be quite significant use for you. So if you have any questions regarding the program, I'll be happy to answer them for you. You can type them in the questions tab. So if you have any questions regarding the webinar, you can type them in the questions tab, and I'll be happy to answer them for you. there's a question that if the software can handle steel and concrete composite beams and slabs. Yes, sir, it can. In fact, the last thing that I showed you, this is the composite beam and slab, which has a steel girder and the concrete deck. It will be clear to you in the section view. So this is steel and this is for concrete. I hope this answers your question. You can even get the section design. I'll go to, yeah. Okay, so if you have any other questions regarding the program, I'll be glad to answer them. So currently the Design Plus can handle the American codes and the Euro codes. The incompatibility might be arising because the design code that you've used in Gen, that's not yet available in Design Plus. So you'll have to design it with the same code, and then there'll be no incompatibility between Gen and Design Plus. So this was an answer to the question asked that if there's an issue of code incompatibility between Gen and Plus, so how do we resolve this? So I hope this answers your question. You can select the design code from here. You can go to steel options, double click on it and click on design. You can get the section list from here where you want to keep which one as a default section, or you can go to option, design option for steel. This is the design codes that are available for RC. These are the design codes that are available for SRC. These are the design codes that are available. And in the coming feature, we'll have the aluminium design also. If you have any further questions regarding the program, I'll be glad to answer them. Okay, so I thank you all for attending today's session. And if you have any further questions, you can write us an email at techsupport@midasit.com, and we'll get back to you with an update within 24 hours. So if you have any questions regarding Design Plus or Gen or any of our other products, you can shoot us an email at techsupport@midasit.com, and we'll be glad to help you. So thank you for attending today's session. I hope it was useful for you, and we'll get back together in the coming weeks. So thank you for attending today's session, and I wish you a very good day. Yeah, okay. Before I close, there is a question that if we can go through your models, if the tech support can go through your models. Yes, sir. The technical support team, from which I am a member, we are able to check through your models for you. If there any clarification you need as to why such an error or a program, why program is giving such results, we can go through these models for you and let you know where the error lies. So if you have any problem, you can email to us and we'll see how we can help you. Okay, so I'll end the session now. So thank you and a very pleasant day to all of you.